Chapter 19, confidence intervals. For proportion. All right, because of sampling variability, we know that our sample proportion p hat is not exactly the population proportion, which is p. So a confidence interval will allow us to create an interval. This thing is like freaking out. I don't understand what's happening. Will allow us to create an interval around p hat that we have a certain confidence contains the actual population proportion. When we estimate the standard deviation of a sampling distribution, we call it standard error, or SE. And the formula for that is SE of p hat. So standard error of p hat is equal to the square root of p hat q hat over n. The normal model tells us that 95% of all samples will have p hat within 2 standard errors of p. So if I reach out plus or minus 2 standard errors from p hat, I am 95% confident p is in my interval. So that's like the 68, 95, 99.7 rule is where that's 95% is coming from.
I forgot. Why don't it go to 100?
What do you mean?
Like,
That rule?
Yeah, I forgot.
Because that's just up to 3 standard deviations. So the other 0.3% is outside of 3 standard deviations away.
Someone had told me that.
Yeah. It is kind of weird because they don't really, like, ever mention that. But it could be all the way out to, like, many, many standard deviations away before you ever actually get 100%. So. A 95% confidence interval can be interpreted as being 95% confident that the actual P, the population proportion, is within our interval, or it could mean that 95% of samples of this size will produce confidence intervals that capture the true proportion. Confidence intervals. One proportion Z interval. And on the calculator it'll say one prop Z interval.
Do you have any lotion in here?
I do not, but if you convince one of the girls to in the girls' bathroom, there's a whole bottle of lotion in there.
Like nice lotion?
I mean, yeah. I mean, it's not like
That's
smelly.
It's not it doesn't smell good?
Well, no, I'm saying it's not like Bath and Body Works that has like a perfume smell. It's just like a
Regular lotion, man.
generic lotion.
It's not,
But I mean, one of the girls would probably be willing to get it for you.
Mhm.
Also, are your nails painted?
No. I got frostbite.
They're painted.
Why?
It's just a thing these guys are doing.
Okay.
I don't know why.
You're not gonna join the trend though.
No.
Okay, good.
That's highly questionable. In my
Oh, I agree. I just wanted to check. I also don't think you know what frostbite looks like, because that definitely was not it.
Yeah, I mean, they were painted black, so it can't be frostbite.
All right. So, anyways, the one prop Z interval is p hat plus or minus 2 standard errors of p hat. The extent of the interval
Is that a P or a D?
it's right here.
Yeah.
It's a p.
Uh,
Is called the margin of error, or ME. In general, all confidence intervals take the form of estimate plus or minus margin of error
Nah, I get my nails painted clean. If I'm like going to a nail salon or something. Nah,
Wait, is that what he did?
no, he didn't. No, he just. I guess he just got some paint and painted him himself.
My gosh.
I mean, I know guys like they get like mani pedis and they get clear polish. So like.
Well, yeah, okay, that's fine.
It preserves the nail, but that's just.
Or like if you're like a chronic nail biter, because then you have something to like pick off.
Yeah, that's just.
That's weird. Maybe you should have a heart to heart with them.
No.
It goes with the nice jewelry.
A lot of guys do that too.
And I say that very, very sarcastically. All right. If we want to be more confident, we have to increase the margin of error the larger the interval, we could create. Wait. Hold on. That doesn't. Oh. End. Next thing. I was like, wait a second. We could create a smaller, more precise interval but we would have less confidence in it. To change. What is happening? The confidence level we need to change the number of standard errors. This number of standard errors is called the critical value of Z. Or Z star. So memorize this next thing because you're going to need to know it. For 95% confidence, Z star is equal to 1.96. to the problems.
Yeah, but like,
It's just it'll ask you. It'll be part of the formula for what gets plugged in. More so with the margin of error stuff. It'll make sense in a second when we do an example. Or well, it'll start to make sense. It probably won't completely make sense yet. So, again, we have some assumption. Whoa, not that. Some assumptions like we have been having. So, surprise, surprise, we have an independence assumption. Check. Randomization. Check. 10% condition. Sample size. We're looking at success failure. NP greater than or equal to 10. NQ greater than or equal to 10. This next thing will kind of answer your question that you just asked. If it decides it wants to work. The 1 proportion Z interval when the conditions are met, the confidence interval and honestly sometimes you'll see that written as CI, so I'm just going to note that really quick. Confidence interval for the population proportion P is P hat plus or minus Z star, and that's dependent on what confidence it asks for. If it asks for 95% confidence, that would be 1.96. It's different for other confidence levels, whatever. Times standard error of P hat, where standard error of P hat is equal to the square root of P hat Q hat over N. All right, so an example. Gallup asked 510 adults if they believe the death penalty is applied fairly. And the results were that 60% said it was applied fairly, 35% said unfairly, and 5% said don't know. So then what can we conclude about the opinions of all adults? So our focus of what we would be trying to do here is to make a 95% confidence interval of the true proportion of U.S. adults who think the death penalty is applied fairly. So, as has been the case for the past, however many sections, we check the conditions. So, is each person independent of the other?
Are they independent?
So is your opinion gonna affect my opinion? No. Okay, so independent. Is it random?
You.
Yes. And 10% condition? Are 510 adults less than 10% of the entire adult population?
Yes.
Yes. Then success failure. N times P hat, okay, or NP, it doesn't matter how you look at it, is 510 times 0.6. That comes out to be, or do you want to try to figure it out?
That is 306. And that one is 204.
What?
Is that what you said?
Yeah.
Okay. But then that's what I thought, and then I thought you said 40, and I was like,
That's what I said, 204.
So, met, meaning we can use a normal model. So, N is 510. P hat is 0.6. Okay, so the failure is the people who said it's unfair or that they don't know. So yes, there were technically 3 things in this one, but we're looking at it's either fair or it's not, or they don't know, basically, or those two kind of get grouped together. So that means then that Q is 0.4. So I need to find standard error of P hat, which is the square root of P hat Q hat over N. So 0.6 times 0.4 over 510. Are you going to be ambitious, or? You really don't have to be, but if you want to be.
0.24 divided by
It's a really small number.
Yeah, I kind of figured it.
That is 0.00047.
Okay, and then the square root of that.
Point 0.022.
Okay. So now, because the sample is normal, for a 95% confidence interval, the critical value Z star is equal to 1.96. So then we can use that for finding margin of error. So margin of error is equal to Z star times the standard error of p hat, which is 1.96 times 0.022. Which is 0.043. So then our actual interval, okay, is our p hat plus or minus our margin of error. So this is 0.6 plus or minus 0.043. So our official interval, if it wanted you to actually write it out, because sometimes it will, you would actually solve this. So like 0.6 plus 0.043 would be 0.643, and then 0.6 minus 0.043 would be 0.557. So that would actually be your interval, but the number above is how you find it. So it just depends on what the question asks. When you do it on your calculator, it's going to give it to you like this. So then these problems all require a conclusion, unfortunately.
Wow.
They just do.
You have a conclusion.
You have to explain what it means in context. It's a nice favorite question of the AP test. So I am 95% confident that the actual proportion of U.S. adults who think the death penalty is applied fairly is between 55.7% and 64.3%. All right, so with sample size, there's the hypothetical possibility that we don't know what the sample size was originally, so we may have to find the sample size. So this can be determined by choosing a margin of error So it would be something like ME for margin of error is equal to Z star times the square root of P hat Q hat over N. And you would solve it just like you would solve, for a variable normally, solving for an unknown. Sometimes, depending on how it asks it, we don't know P hat. So if we don't know P hat, use P hat is equal to 0.5 and Q hat is equal to 0.5 to find the largest N. So if it doesn't specify, consider it basically a 50-50. So an example of that, if we wanted a 3% margin of error, and that's all we were told, we would do 0.03 is equal to 1.96, because we're going to do it for 95% confidence. So 1.96 times the square root of 0.5 times 0.5 over N. So I assume you would know how to solve this equation. So 0.03 divided by 1.96. Then square both sides, so square that number. Then basically flip the two numbers, so let's see, let me do this way. 0.5 times 0.5 divided by the number we just got. So N would be equal to 1,067. So on the calculator, we hit stat, test, and then it's letter A, which is 1 prop, Z interval, X is the number of successes, which is a count, so we need whole numbers. N is the number of samples. And then confidence level will be also what it asks for. And that can be anything. It can be like 0.95, it can be 0.99. I mean, it can be whatever they ask for your confidence level. The most common one that we'll use is the 95% one. So, but you won't type in like 1.96, like you would type in 0.95, and that's what they would use for it. So then just a couple of things to just be aware of, watch out for, blah, blah, blah. Be careful how you interpret your interval. There are many incorrect interpretations. Watch out for biased samples. And think about independence.